Hi guys, I hope your Friday's going good. So here we go. We left off on perpendicular on Wednesday, so I'm just going to do, and we did this one here. So we're going to do the second one here. So if you're struggling, you can hopefully watch the video and figure it out. So my first step would be to solve for y. So I'm going to subtract x on both sides. And then I'm dividing everything by -2. Which makes that y is 1/2 x minus 3.5. Well, I really only care about the slope, the m. So the slope is 1/2. So if I want to write the perpendicular line, I flip it and I change the sign. So the perpendicular slope is 2/1 flipped, and then it was a positive, so I make it a negative. So this is the slope I want to use, this one right here. So my point, my x is -3 and my y is 2. So I'm plugging them all into y equals mx plus b. So 2 equals -2 times -3 plus b. And I subtract 6 on both sides. So b is -4. So I use both of these pieces of information to write my answer. And there's my answer. All right, number 6, create a mapping for the set of relations. A mapping are the two ovals where I put all the x's in the first oval and all the y's in the second oval. Remember, the big thing here is that you can't repeat the numbers. So if there's a repeater, you only write it once. So -1, 0, 2. And there's another 2, but I only write it once. And then for the y's, I've got 3, 5, 4, and -2. And then arrows connect to show what the order pairs are. So -1, 3, 0, 5, 2, 4, and 2, -2. So that's what my mapping looks like. So these are my x's and these are my y's. Well, they're also my domains because domain and x are the same thing. So when I write the domain, I put -1, 0, 2, and 2. And my ranges are my y's. So that's 3, 5, 4, and -2. And it's not a function. And it's not a function because there are two 2's in the domain. See how there's 2 arrows coming off this 2? That means it's not a function. All right, find the range. So I'm finding the y's when given this equation. So I'm going to make a little table and plug them in. And these are my x's. So the domain is this. That means x are these. So I'm plugging these x's into the equation and popping out some y's. So -3 times -1 plus 1, that's 4. -3 times 0 plus 1, that's 1. -3 times 1 plus 1 is -2. And -3 times 2 plus 1 is -5. So my answer would be the ranges, which is 4, -1, -2, -5. All right, is it linear? Linear means line. Okay, I know if it's a line, if it's written in slope-intercept form, or it could be written in slope-intercept form. So I know since this first one has a little 2, it is non-linear. And I know since this is in standard form, ax plus by equals c, I could convert it to slope-intercept form, but I don't need to. So this is linear. All right, these are plug-in chugs. So notice that f of x, I have f of 4. 4 took the place of the x. So I take the 4 and I put it right in there. So 4 squared minus 3 is 16 minus 3, which is 13. I do the same thing with the -5. It's in place of the x, so I replace the x. -5 squared minus 3. So make sure if you type this into the calculator that you put those parentheses in there, because if you don't, it will only square the 5 and not the negative, and you'll get the wrong answer. So this answer is 22. All right, it's a function if it can pass the vertical line test. The vertical line test says that a vertical line can only cross the picture one time. So one time, right there. So since it's only crossing one time, no matter where I draw it, this is a function. And over here on this absolute value equation, it's crossing twice. So since it's crossing twice, this is not a function. All right, is the relationship linear? Well, it's linear if it has a slope and a b. Well, the b is right here. Since x is 0, that makes that 512 the b. or the y-intercept or what the camera starts with. And then it looks like as I take pictures, more of the memory is used. So each picture, it looks like it's using, because this is going down by 3 each time, and the photos are going up by 1. So my slope is -3/1. So my equation, -3x plus 512. 512 is the starting point, and I'm using 3 units of memory, whatever those are, because it doesn't tell me, um, for every picture. So that's my equation. Okay, draw the graph that represents the situation. All right, a child has a normal temperature of 98.6 degrees at 2 o'clock. At 5 o'clock, he spikes a fever of 103.5 degrees. Mom gives him Tylenol, and at 6 o'clock, so not very long later, his fever is reduced to 99.2 degrees for 4 hours and then rises again. All right, so if I make a small little graph here, this would be 0 down here. He didn't start at 0. He started at 98.6 because that's the normal temperature. And he had that at 2 o'clock for a little while. And then at 5 o'clock, he spikes a fever of 103. So it goes up to about 103. And mom gives him Tylenol at 6 o'clock. So he has the fever for a minute, and then mom gives him Tylenol, and it goes down again. And actually, it didn't go down that far because it didn't go down to 98.6. It went to 99.2. And he had that for about 4 hours, which is about this long as well. And then it goes back up to the 103 because the Tylenol wore off. So there's my graph. So something like that. Notice it didn't start at 0 because his temperature did not start at 0. All right, a parachuted man jumps off the top of a hill at 400 feet. So it's going to start up here, 400 feet. He drops quickly to 300 feet immediately. Boom. And then he coasts at 300 feet for 2 miles. So he's going to stay at 300 feet for a minute. And then he slowly starts to decrease in altitude until he touches the ground. Notice the slopes. Notice when he went from 400 to 300, it was a steep slope. Notice he stayed at 300 feet for a little bit, and then he decreased slowly. Notice the slope, how different the slope is there. All right. And then Lindsay starts at home and runs to school as fast as she can for 1 mile. She stops for 5 minutes and takes a break, then continues walking on to school for 4 miles. So here's the beginning school. She starts it and she goes really fast for 1 mile. So her slope, really quick. She covers a lot of distance. And then she stops for 5 minutes. So time is moving on, but her speed and her distance are not moving on. And then she continues walking to school. So her speed is represented by the slope, but the distance is represented over here. This is distance, and this is time. Okay, and then over here would be getting to school. Okay, so she walks slowly. So notice the slope is much, much longer because it's 4 miles, and it's also much less steep. Okay, that's it. So we did the rest of those on Wednesday.